Okay. While he's setting up my laptop, good morning, everyone. Excited to be here. While this is being set up, a few questions. How many of you are from the business, product, legal, compliance side? Awesome. Good to see some product managers. I'm product myself. How many of you are AI practitioners? It could be engineering, it could be research. See a few show of hands. We have a few members from my team. Awesome, that's great. Okay, cool. And how many of you are youth innovators? I see a group of folks here. Awesome, welcome. Okay, so today I'm going to be talking about three things. First, give you an introduction of how we do AI at eBay at scale. And where computer vision fits in. Secondly, I'll walk you through computer vision use cases, and specifically we'll take one use case, which is the image cleanup use case, and tell you the story of how we went about solving the problem with computer vision. And lastly, what is the underlying engine that would actually power computer vision at scale? So those are the three things. We'll go starting at the 10,000 foot level and slowly drill down. Question. How many of you know the story of eBay, and what was the first item that was ever sold on eBay? Does anyone know that? First item 20 years ago when it was founded as an internet startup. Any guesses? Yes. Beanie Baby, close guess. It did get popular, yes, but something else. The founder sold something. I'm going to give you a clue. It was a laser pointer, and that too a broken laser pointer, by the way. It was a broken. Another question. How many of you use eBay here? Awesome. Thank you for being the customer. And how many of you sell on eBay? Wow, thank you. Double thank you to you guys. So we will talk about image cleanup as a seller. Hopefully you will like that new feature that we just rolled out yesterday. And hopefully for others that are not users, hopefully you'll get excited and start using eBay and give it a try. So as you all know, eBay has been a 20 plus year company, and we are a global marketplace. We are in over 190 markets, 1.4 billion listings, right, live. So that's massive scale. And there are a lot of stats in here, but really the key takeaway is tons and tons of data, right? And that's the perspective that I want you to take away from this slide. How do we do AI at scale when you have 1.4 billion live listings with millions of buyers and sellers, and how do you identify their needs and wants and fulfill their shopping intent? The other thing is, you might have heard in the big data world about volume and velocity, right? Just look at the immense velocity in which data flows through, right? In the US, a watch every 5 seconds is being sold. In Germany, there are parts every 1 second. And you'll be surprised that we have quite a few new items, 80%. So it's not just like your flea market. We have new items. We also have fixed price, not just auction items, and ships for free. So there is a lot of shopping opportunity here for you. So that's my spiel for you to start shopping on eBay. But interestingly, that's a lot of data. Now, how do we look at it from an AI standpoint? So it's kind of think of this as concentric circles. On the outermost circle is our user experience, like folks like you and me, buyers and sellers. They start with listing, and then as a buyer, you may come and browse, you may search. And then once you connect with an item that you're interested in, you basically transact. And then the seller, you can also give back to charity, which is a huge program at eBay. And then we ship, you receive as a buyer, and that's really closes the loop, right? Then there's always things about giving feedback for buyers and sellers. If things go wrong, we have a trust and safety program as well. But that's our user experience at the outermost layer. But what is the AI that is actually powering it? We call it as the user AI. And this is basically a set of AI that's very close to the experiences. This could be your seller experience, your buyer experiences. We have shipping for logistics and price prediction, as well as delivery estimates. But at the core of this, we call these as our core AI pillars. This could be your natural language processing, your search, relevance and recommendation engine, your price prediction, economics and logistics, recommendation engines. And you see that vision AI? That's really what computer vision is. And we'll kind of double click on that in the next few slides. But at the core of that is our eBay data, those 1.4 billion listings we talk about, buyer data, seller data, behavioral, transactional, all of that is in that eBay data powered by an AI platform engine. So when we talk about our core AI pillars, computer vision is definitely there, but these are our, again, a 10,000 foot level of how we look at our AI pillars. Search and recommendation. So when you as a buyer come to eBay, how do we know, what is the relevance that we need to provide you with? How do we rank items? We have sellers that are coming and placing ads on our system. How do we do organic listings and combine them with ads or premium listings? So that's really a search and recommendation. Or same thing with the recommendation engine, where let's say you buy an iPhone. Can we actually recommend that, hey, here is a complimentary adapter for you, right? Or people that actually viewed something like an iPhone, hey, maybe you might be interested in something like a next-gen iPhone. So those are our search and recommendation engine. Computer vision, we're going to double click on this. Natural language processing, it's a big thing for eBay, all the way from understanding your query intent to understanding structure in the data, right? Named entity recognition, trying to map that to your search queries, being able to translate, that's a big part. We are a global marketplace, as you saw. So if a listing, let's say, is created by a seller in Great Britain and a buyer in Germany would like to view it in German, can we actually enable that across our millions of listings? That's enabled by natural language processing. And then personalization, right? Knowing who you are, your intent at that point in time when you come in for search, combine that with your historical purchasing and commerce behavior over time. That's really what our personalization engine drives. Economics and logistics. We have several tools for our sellers that say, hey, what is the best pricing? What is in demand? And then when you actually, as a buyer, come in and say, hey, can you actually ship this? We provide delivery estimates for when you might be able to expect the delivery of your product. So that's really the core AI pillars. And now we're going to double click into computer vision. So when we started framing this computer vision for computer vision, we started looking at it and saying, okay, what does really mean? We get over 50 plus million images a day. So when you take a listing, there's a gallery image, there's tons of other images as a seller you could post, right? Because you could say, hey, here's the front image, here's the side view, here's the top view, right? Or if you have we call them multi-SKU, right? So you could have a t-shirt that you're selling, this is red in color, but there could be things that are blue, cream, right? Polo t-shirts. So we get tons and tons of images, right? Going back to the 1.4 billion live listings, imagine how many images we need to have if it's like 8 to 10 times. So these are petabytes of data. So we said, okay, what do we really need to do in order to enable computer vision at scale? So we came up with these big themes. We said, number one, it has to be magical, right? Because with computer vision, we can create wonderful, inspirational things. And these days, smartphones are getting so much more exciting, so much more powerful. So how can we make that happen? So let's say you are shopping for a dress. Can you actually make it cool and a fun-loving experience? Trusted, it's a big issue for sellers and buyers. So when you buy an item, can we actually detect if things are counterfeit or not? If an item is prohibited, can we actually detect that by just looking at the image? So that's something we are big into with computer vision. The other is frictionless. We all want to get things done quickly. How can we make that happen? Can we use, for example, you're coming and listing, you're a seller and you want to list your, let's say your iPhone or something like an old dress. Can we actually look at that image and infer characteristics of that particular product and make it very easy for you to list? So these are the broad themes that we looked at and say, how do we take this and proliferate this across of our eBay user experiences? So that's kind of what we defined when we started on our computer vision journey. So specifically, I'm going to be talking about 4 areas. One is visual shopping. Many of you might have heard of image search, visual shopping experience. We'll touch upon that. I'll talk about a seller new feature. It's called image cleanup. How can you do this on the device? And then how do we infer characteristics, attributes of images and enable them for eBay experiences? Finally, AI platform. This is a transformation we embarked on 3 years ago to transform how AI was done at eBay, all the way from the bottom of the stack, from the infrastructure layer to our AI application layer for computer vision, for machine translation. So let's get started with visual shopping. So some of your computer vision practitioners, this is a no-brainer. When we start looking at it, there is a spectrum as to how we talk about computer vision, right? We say that, hey, where are the objects? We talk about object detection, right? So all the polygons. So say, hey, room full of furniture. This is from our home and garden category, an image on eBay. And you can say that, oh, okay, here are the objects. I just want to detect what those are. The next thing that we want to be able to do is recognize the objects, right? Like, hey, there's a chair. What category does it belong to, right? What is its style? What is its color, right? Now, as a buyer, you might be holding a camera and you might be pointing to the chair and say, okay, you may be in one of those retail stores, right? Or maybe you're in, I don't know, IKEA, in Target or anywhere, and say, now I need to check what is the online price comparison. Can I get something cooler but similar looking with a low price on eBay? So then we talk about, can you actually find these and show across the 1.4 billion listings, can you find similar listings looking at the characteristics of the image? So this is what we enable with our visual shopping experience. So you take a picture, you can upload a picture, or you just point your camera. How do we actually detect, recognize, and then find matching objects? Now, doing this at scale is not easy. Like I said, just in the category home and garden, you might find, again, millions of listings. How do you actually identify that, right? So there is a model training lifecycle that goes into, and then there is what we call as a model inferencing and indexing lifecycle that goes through. But this is, again, some snippets of what you would experience as a user when using our app. This feature is available. It's almost been 2 years since we rolled this out. A lot of good reviews. We are continuously improving the algorithms behind this, continuously improving how we index, how we look up our matches. But as you can see, there's chair. You might get some results. And then, hey, okay, you start on it and say, oh, you know what? I like this red purplish chair, so I want to go in and say I want to find more that looks like this, and then you start getting and diving. Then ultimately you may say, you know what, maybe teal may look better than purple. So what we're trying to do here is use computer vision to first take an image, understands the aspects out of it, and then match those to the billions of listings, and then help you fulfill your shopping journey. The other thing we also do is, in the back, we always look at it as multimodal, because as humans, when we talk about AI, it's not like, oh, it's just images. We also use language. So one of the things we tend to do is we try to mix image, text, as well as the categories that we have detected to narrow down from those 1.4 billion listings to a set of listings that would actually make sense for you. So that's our visual shopping journey. As a buyer, this is what I'd love to have you guys try it, send us your feedback. The next one is image cleanup. Now, this is a feature that we just rolled out. It's ramping up in the US, in iOS and in Android. But what I'm going to do here is actually walk you through the journey of how we went about solving this problem. Because it's a really nice story to talk about how AI comes to life in an at-scale company like eBay. So this is something that we did last year. So the selling team actually came. So we have the buying and the selling team. So the selling team, they came to us and said, you know what, one of the things that we found when looking at our user research of buyers and sellers, clean looking images actually help. Like when we all know, right? When we're shopping, we all don't like to see cluttered image. White background actually sells more. So that was the findings that they came back and said, hey, can you guys actually help us here? Because for the sellers, when they have these nice looking images, it could be on eBay, or when they send those as ads to systems like Google or Facebook ads, clean looking images click better engagement. So they said, you know what, as a selling team, can we partner with you guys? You guys are computer vision, image experts. Can you do something cool to make this happen magically? And because then it goes to the buyers like it, and then they actually start buying more of this, because seller velocity is very important for the selling team. They want their listings to be sold. So at a high level, what is image cleanup? So this is a picture of my wife's sunglasses. I put it on the washer dryer at home. As you can see, this is some of the typical, what we call a C2C, consumer to consumer sellers that actually list. We have B2C also, by the business to consumer. Those are nice looking catalog images. But here we're talking about primarily C2C images. So you can see there is some socks on the top. It's got my shadow. Lighting is not that nice, right? Now, what does image cleanup do? Simplistically, you take that image, clean up the background. Now, when you have the listings like this, people tend to click more. They engage better. Now, this is not the case for everything, right? In some cases, yes, there are cases where you want to see the background. Like, let's say the case of a chair. You may want to put it in the corner of a room and give the perspective of the entire room. But we're talking about specific set of use cases where image cleanup would actually make sense. So this was the problem that we actually went after, simplistically, right? So when I was trying this out, my wife was like, okay, don't you dare sell this. It's my favorite sunglasses. I said, no, it's just for the presentation. Okay, anyway. So when we started down this journey, we said, okay, let's look at the data, right? All you AI practitioners, we always want to look at the data, right? And we said, you know what, only 5% have white background. And half of them actually have very complex composition, and we'll talk about what that means, right? So now on the good side, for the AI practitioner, lots and lots of diverse data set is awesome, right? You guys agree? AI practitioners, we want diversity, right? But at the same time, it creates problems for us in terms of a product experience. So we said, okay, let's look at some of these examples. There are the simple scenarios, right? You just get started, hey, plain background, there's different contrast between the foreground and the background. Cleaning, except some we don't even have to clean up, like the first two maybe. Last one, orange and brown, you probably know, hey, this is the foreground, that's the background, what is the primary object? There's only one single object. Now let's look at some of the why when it gets challenging. You see the car seat here, lot of clutter in the background. Some cases, improper lighting. And I love that, the horse, that's a really funny looking. You can't even make out that's a horse, right? Except for the rear of it with some dotted. But anyway, so we get images like these, right? So, but then part of it is we need to look at it and say, okay, is there a lot of clutter? Is there reflection? Is it actually, now for the human eye, we perceive it. We know that, hey, there is a box of Guitar Hero on a blanket, somebody clicked on a bedroom. Imagine a computer that's processing the image, right? How does it detect? It's a very challenging problem. When we have loops, it gets tricky. When we have thin regions, it gets even more trickier, right? We're talking about jewelry, right? That gets really tricky. And sometimes transparency, that also causes problems. So how did we actually evolve this, right? Now, from an experience standpoint, over time, our computer vision, we have our researcher here, Cha Song, who's sitting at the back, wonderful work he did. But it was very much in collaboration with our design team, product folks, as well as our computer vision and engineering team, right? So we said, I'm going to play some snippets of videos here. Hopefully the AV will cooperate here. So we said, okay, you know that not every image can be cleaned up. First, what we want to do is we say, hey, can I go back to this one and look at what we call as, can we even do a good job of cleaning up the image, right? So first we look at it and say, or give the user some visual cues, right? Hey, maybe you want to take it in a good lighting. Maybe you want to take it with a bit of a better background, no clutter. Now, once we detect that we can actually separate the foreground and the background, then we actually allow the user to crop the image itself. So in some way, it gives the algorithm, right? So part of it is we let the user be involved in the process. They own the cleanup, right? And we've heard user research which actually points us that when users feel more in control of their listings, they really like it, right? So, and then one of the things we do is, okay, the user's done it, they're focused on the main part of the image that they would like to clean up, and then we actually do the automatic cleanup. We take a pass at the auto cleanup. Now, as you can see, simple images with contrast is very easy. But once you start having these kinds of loops, transparency, it gets really, really tricky, right? So then we said, okay, what do we do about it? So we actually said we'll also do what is called a manual touch-up. So in this, what you end up doing is we give users like, a brush and an eraser, a zoom in, zoom out. So they could actually come in and zoom in and do the cleanup themselves, right? So what this actually means is we give more control to the users. We tried at some point, we want to make it magical and frictionless as much as possible. So the best case scenario is we don't want the user to be able to do this. But there's always these complex scenarios. So then we actually let the user do this. Okay. Now this entire thing is actually running on the device. If you have the latest eBay app and if you're part of the ramp up already, you might be able to see that when you list an item. For the sellers that you may want to try this up with some of this, or during coffee break, I'll be happy to show you some examples. So this is kind of the evolution of how we actually went about creating the experience combined with the computer vision technology. And it was a lot of collaboration, right? Across diverse skill sets, product, design, research, mobile architecture team, across organizations, right? And in terms of metrics, that's something that we start off with. There are product level metrics. How many of our sellers actually end up adopting the cleanup? How many of them do the auto cleanup? How many of them do the manual cleanup? Right? So we start tracking these metrics. And from a product standpoint, ultimately, it's not just the seller side. We want to know how many of the buyers are actually clicking on cleaned up images versus other images. So we try to track those metrics. Now, in the algo side, for the AI practitioners, there are specific metrics that we try to do, right? We try to look at goodness score, we try to look at separability. Our computer vision researchers can talk to you about what algorithm actually went into that, right? We're also tinkering with a lot of deep learning algorithms, but at the same time, there is trade-off between how intensive it is going to be when you run it on a small device in a smartphone. So that's where the tech came in, right? It was a combination of the computer vision, engineering, and then we also had to do a trade-off between, do we do this on the device, on the phone, or do we do this on the server side? Because the newer, more powerful smartphones, right, like maybe an iPhone 9 Plus, the X, or the Samsung, or the Android Google Pixel, these have really fast chips. We have folks from Intel who talked about chips, right? So these are really fast chips. They can really run. And you can run memory-intensive applications. You can run processing-intensive applications. But we have a large user base that don't have these modern phones. Now, what do we do with that? And if they want to do this, so we also have like a server side. How do you actually do this? So that's a balance and a trade-off that we try to do this. And ultimately, we have the mobile architecture team that talked about mobile definition of done. When you want to put a feature in the mobile app, it has to comply with certain characteristics, right? Security, performance. So all of that actually goes into this. So when we talk about AI applications, yes, we talk a lot about training models, improving the accuracy, precision, and recall, right? But there is so many of those engineering and product consideration, and that's really the key takeaway here is there is engineering, and Eric talked about this as PMs, right? We try to look at it from an engineering standpoint. We try to look at it from a design standpoint. We try to look at it primarily to say, okay, are we actually violating some of this? And then there's the go-to-market plan. So first, we eat our own dog food as employees. Then we say, how do you open it up to a control experiments with a few sellers? And then we say open access, and that's really what it is. Now we're actually ramping up for entire. So each step of the way, we want to get some validated learning that helps improve the experience, helps improve our algorithm. That's kind of how we go about this whole journey. Okay, 10 minutes. Let's see. Thank you, Gary. So that's image cleanup. So hopefully you got an understanding of one particular use case. We talked about visual shopping for the buyer. We talked about image cleanup and how we went about solving this problem where the selling team came to us and we used computer vision to solve that for our sellers. Now let's talk about attributes, right? So, okay, so here is an image. What can you infer from that? Can anyone say what all the things that can you tell about this image?
It's a red sweater.
It's a red sweater, okay. What else?
Under Armour.
Awesome. Under Armour. Perfect. Awesome. It's cotton. Okay, cool. Okay, we're going to come back to the same example. You guys were spot on, but we'll come back to this. Why is this so important here? So when we look at, I talked about we get over 50 million images a day, right, for our 1.5 billion listings. Now, one of the things that we do is not just on the experience side. When we get these listings, we want to be able to infer characteristics. We call them attributes. And internally, we also call them as aspects out of these images. So how can we detect for example, Samsung or a Sony? And it doesn't always have to be a logo. A logo helps a lot, right? When we actually do the deep learning, that helps. But there are certain characteristics of the box itself. How does an AirPod look like? Or Home and Garden, for example, the IKEA lamp. There's no logo in there, but you could actually tell that's maybe an IKEA brand. Again, some of you said about, hey, this is like a hoodie, right? So neckline. We could look at patterns. We could also look at whether it's striped or then what brand it is. And then obviously occasion, right? Fashion is a big part of eBay. So we also look at, okay, what are the types of occasions that different clothes can be worn. And then there is the plethora of other categories, right? Like for example, jewelry, amber stones, then brands again here, carriers, MacBook Air. So why is this important? Going back to the hoodie Under Armour, right? When you look at the from seller, when sellers actually list, we request them to list a few attributes. Some of them do that, some of them say, hey, we don't want to do that, or some they don't know, right? So they say hoodies, red, solid, Under Armour, the blue column. But then what can we infer from this, right? I'm just listing a few here. You can see that somebody said hoodie. We can match it to the category that in the eBay taxonomy, right? We can look at the style, just like the floral dress or the occasion, we can say this is a hoodie. What is the primary color of the primary object, right? So you can see that it is actually, so that enables when you as a buyer want to come and shop in the mobile app, you can say, hey, I'm looking for like a red hoodie, and through a color palette, you can actually search and then you will be able to get to this. Then it's a solid pattern, like someone said, the brand is here, we can use it for all seasons. And then is it explicit content or not, right? I'm going to say a few things here about the extra attributes that are not in here, right? So what is explicit content? We get a lot of images that have explicit content, right? Adult content. And we try to detect that. Remember I talked about trust. One of the things we try to say is, okay, is this safe to actually show it on eBay? Can we detect if this is a counterfeit or not? Can we detect if an object should not be stolen in the US or in Germany? So there are a lot of things where even some sellers, they try to circumvent our systems. So what they try to do is they may put like, okay, email address on this and say, okay, they don't want to pay fees through eBay. So they say, okay, just call me offline or transact with me offline, right? So we can actually detect quite a few things just by the image itself. So there are things that we look at, the aspects and attributes. We can look at text, we can look at patterns. And that really helps us to scale for eBay. So we have these images, millions and millions of images that flows through our AI platform and computer vision. We call it CVPaaS, Platform as a Service. And when it comes in, we map those two categories. Right, this could be home and garden, it could be leaf level, we call it leaf level category. And then we extract these attributes. We also generate embeddings. For some of the AI practitioners, we generate embeddings and we actually make them available in our offline stores for you to actually come in and train. And then depending on the user experience, teams can actually leverage these attributes, right? So for example, if your search you want to come and enable an experience that says, I want to search for a teal colored, a cushion for my sofa. You could actually come in and search. And if you want to filter out explicit content, then you can do that. If you want to detect bad actors from a trust standpoint, you can look at, hey, the listing title does not even mention a word Nike, but you're actually putting that in the image, or we can detect phone numbers. So the key takeaway from this slide is, it's not only that computer vision is enabling on the experience side, how do we extract attributes or metadata out of these billions of listings and make them available across of eBay globally? Now, what is the underlying AI platform, right? I think the previous speaker talked about change. So we also embarked on a journey about 3.5 years ago to transform how AI is done at eBay. And part of the journey, I've actually blogged about this in December. If you go to the eBay tech site, you will see this, is our AI platform. For the AI practitioners, this might be very familiar about, there's data, there's AI modeling lifecycle, there's AI infrastructure, and the entire lifecycle that happens. But really, for computer vision, what do we do, right? We have, like I said, over 50 million plus listings that come, images that come in. How do our practitioners continuously train their models, right? We start with the workspaces. They may actually do this in an interactive mode, but they might also want to do like deep learning, right? Hyperparameter tuning. So they actually run this in what we call as pipelines in the workflow engine. And then they can record their experiments in the experiment management system and then push the models to a model repository. So you can actually do versioning of the models, and at the end of the day, you deploy it to a model serving architecture, which is where the inferencing actually takes place, right? So the serving engine supports different types of model architecture. So you could do like a CPU-based inferencing, you could do GPU-based inferencing, supports TensorRT, all of those different model formats. And the key thing is the feedback loop, right? So how do you get the learnings out of how well your model is performing back into your training life cycle? So that's something that we have also built as a feedback loop. And powering that is our internal AI cloud infrastructure, right? So folks from Intel and NVIDIA, that's really what is powering our infrastructure. So day in, day out, we have hundreds of our data scientists, researchers coming and training this, their life cycle, managing the entire life cycle, all the way from your natural language processing use cases like BERT training of models, computer vision folks, recommendation folks, everyone coming and using this. So anyway, to sum it up, we started on this establishing the vision of how do you enable magical, trusted, and frictionless experiences. We are on the journey, and we're super excited about enabling more and more such experiences. New use cases pop up. Our product and domain teams come to us, and we just like partner with them. We learn every day. Again, the technology with computer vision is also advancing. We take those learnings and then we bring this back. We also love to share it with the industry. So we've done quite a few things that are open source. You can see that on the eBay blog. So that's it. Questions? Yes.
Let's thank him for his talk first. Thank you.
Thank you.
All right, questions.
On your previous slide, if you go back to it, there was the model servicing block diagram right there at the end.
Mm-hmm.
I assume that's the inference model that's
Yep.
serving the app.
Mm-hmm. Yep.
What is being collected from that to give you additional observability and model performance? Is the arrow going up to the top? What are you looking at from that inference engine?
Yep. So there's a few things, right? So one is at a product level, we try to understand different things, right? Like behavior, right? How are the users actually interacting with it, right? Now, in terms of a particular AI model itself, we try to get the request and the response and what features, right? So we try to log them, and then that is actually sent back to our research teams. So we tend to do both at a product level we collect, and then at an algorithm level also we tend to collect.
Other questions?
If you can you talk a little bit about the hardware constraints that are the biggest hurdles in any of these block diagrams as you go through the process?
Yes, there are always constraints. So obviously, computer vision practitioners are the compute hungry workloads, right? So and these days we got GPUs and TPUs that are actually pushing the state of the art, right? So even, for example, even players like Intel are coming up to it, right? So one of the biggest challenge for us is how do you keep the GPUs saturated continuously, right? That's a big problem. And because when we talk about image stores, having them remote sometimes is not helpful. You need to have them on your local, right? So how do you actually partition your data and load it up upfront to keep your GPUs saturated continuously, right? And then basically kind of evoke in a way that there's on-demand scheduling of the jobs, right? So that's really one of the challenges that we are trying to look at it and say, even when we look at our rack profile, for example, and our nodes as to what we started training on, for example, the NVIDIA V100s, right? So we're looking at it and say, okay, can we actually have inter-node communication? Can we make sure that data is close to that particular rack and not across the rack? So you're not actually having to jump. So those are some of the constraints. I'd love to chat a little bit more in detail during our coffee break, but that's really how we work closely on the AI infrastructure with our hardware engineering and the AI systems team to optimize our rack profile, our SKU profiles for computer vision workloads or natural language processing workloads.
Thank you. We are going to, one more quick question.
Can you please tell in this diagram, like how big is the team is, and like what kind of, like, is it like small teams and like to do all this work? And yeah, like if you can tell some details or elaborate on that.
So one of the things, I will point you to my blog that I wrote in December, because it's not just one team. In a large organization like eBay, where there are hundreds of practitioners, it takes not just a village, you can call it a city to enable this, right? So at a high level, I'll just talk about, there is one owner for the AI platform team, that's my team that is responsible for that. But data is owned by a different team, right? Infrastructure, like I said, hardware engineering actually does hardware optimization for us, right? And then similarly, over time, we've also unified different systems together and brought it under the umbrella of the AI platform, right? So if you actually go to the eBay Tech blog, it talks about how did we actually build this team structure. We call it the initiative core team of different stakeholders, AI practitioners, architecture, systems, hardware, data. We brought all of those teams together in a unified approach to build one unified platform for eBay.
Okay, let's thank Ashok one more time for his talk.
Thank you.
All right, now we're going to take